Hey guys, these are the Newton's laws notes, and they also have mass and weight at the end of them. All right, our first law is called the law of inertia. It says that an object at rest is going to remain at rest, an object in motion is going to remain in motion, unless an unbalanced force acts on it. So basically, it's going to keep doing whatever it's doing unless some force acts on it to change that. Right? Inertia is the tendency of an object to resist changes in its state of motion, which is why it goes with the first law. So your mass impacts this amount of inertia. The greater the mass, the greater the inertia. So if we have a bowling ball and a tennis ball, the bowling ball is going to have more inertia. It's going to resist its change more, right? Which, if you think about it, if you apply a force to a bowling ball, you need a bigger force or a stronger force than you would to move a tennis ball, right? So between the two of them, the bowling ball is going to have more inertia. The tennis ball is going to have less inertia, right? An example here in this picture, you've got this giant rock in the back of this truck and it wasn't tied down. So when this guy braked, that rock slid forward because it is moving with the truck, and the brakes were stopping the truck, not the rock. So it continued doing what it's doing and slid forward into his cab. This is the same as when you're braking in an automobile. So like if you have like coffee in a cup and it splashes out of it like forward in your car if you slam on your brakes, or when you're riding and you hit the brakes and you kind of move forward in your seat, that's because you're causing the car to brake, and you continue to move forward, which is why you want to wear your seatbelt. Or in a wreck where you're slamming on your brakes, you're really going to go flying. All right. So that's an example. All right. Newton's second law states that the acceleration of your object depends on both your net force and the mass of your object, and it gives us this formula F equals ma, which you'll be using quite a bit, but thankfully it's a pretty easy formula to work with. A is acceleration, F is your force, and m is your mass of your object. And know that 1 kilogram is equal to 1 Newton is equal to 1 kilogram times meter per second squared, which is why this formula works out units wise. All right. For this example, we have a net force of 12 Newton, and we apply it to a 3 kilogram object and a 6 kilogram object, and we want to know which object will have greater acceleration, right? We've got our formula. We plug in our 12 for our force, our 3 for our mass, and we get an acceleration of 4. All right. For our other object, we've got a force of 12 and a mass of 6, and we get an acceleration of 2. So the 3 kilogram object, the one with the lower mass, is going to have a greater acceleration, right? It's going to have an acceleration of 4. All right. So if you go back to that tennis ball and bowling ball from the previous slide, if you apply that same force as the tennis ball and the bowling ball, that tennis ball is going to move faster because it has less mass. All right. So this is kind of common sense in a way. We're just applying a math formula to it. Right. Newton's third law states that for every action, there's an equal and opposite reaction. I'm guessing that you've probably heard this law before in your life. This and the first one are like really easy, and people can quote them without even realizing what they are. So I'm not going to really explain that anymore. All right, this free body diagram question and this one I will go over in another video if you need it. So look for that if you need help with these. Make sure you know how to do these because you will see stuff just like this on your test and on your quiz. So make sure you need to know it, but it's easier for me to do that on my iPad rather than on my computer. So they're in a separate video. All right. Last thing is mass versus weight. My favorite question of the year is on this quiz. It's ridiculously easy, but it fools people every year because you are not paying attention in class and don't know what you're doing. So mass versus weight. Mass is the amount of matter basically in your object. It's the kilograms of it. All right. It does not change no matter where you are in the entire universe. All right. Your weight is your force of gravity. So when we went over types of forces, I told you that your force of gravity on the object is the weight of the object. All right. And that's measured in newtons. We're not in pounds in this class. We're measuring our weight in newtons. All right. So the mass of an object will be the same no matter where, but your weight will change depending on the force of gravity on the planet. So on Earth, this astronaut has a mass of 100 kilograms. His weight would be roughly 980 newtons. Right? If he goes to the moon, his mass is still 100. His weight is now like 162, I think is what that picture says. All right, so his weight's gone down. So he lost weight without going on a diet by going to the moon, right? Because the gravity is different. If he were to travel to Jupiter or to Saturn, his weight would go up because those are larger planets with larger gravities. You're not going to have to memorize any kind of gravities. I will give you all the gravities of the planets that you ever need on any of the questions. But you do need to know that mass does not change no matter where you are, and weight does, because weight is dependent on the gravity. That is where the trick comes in on the question that I ask you. Do not mess it up. Right. But I hope this video helps you if you needed it. Thanks for watching, I guess.